All right, we did it. We're on chapter 11, area. Welcome. All right, what's the area of that rectangle? 4-inch base, 3-inch height. I'm guessing most of you know the area is 12 inches squared. I want to talk about what that means and why we do what we do to get that answer, and then we'll come back to it. So here is the same rectangle. 4 inches base, 3 inches in height, and when I ask you for the area is defined as the number of square units in a two-dimensional figure. So here's the same rectangle split up into square units, where it's 4 inches across on the bottom and it's 3 inches up. So when we say the area is base times height 12, what we're really doing is we are counting how many squares fit inside that rectangle. So the answer is 12. And the reason we just do base times height is just the very essence of multiplication. If I said to count these squares, I don't think any of you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You would see there's 3 rows, 4 in each row. So 4 times 3, 12. That's exactly what multiplication is really doing. It's just a quick way to add a repeated number. So add the number 4 3 times and you get 12. Or add the number 3 4 times and you get 12. So as long as you're comfortable with the idea that multiplication is just quickly adding an arrangement of elements in rows and columns, then the area of a rectangle would have to be its base times its height. Base is how many columns there would be, the height is how many rows there would be. So back over here, when we say the area is 12 inches squared, we're saying if we split this up into 3-inch rows and 4-inch columns, pardon the bad picture, there would be 12 of them. Each one of these squares is called a square inch or 1 inch squared. An inch that has been squared. So that's why the units are inches squared. There are 12 little squares in there. Each one is an inch on every side. They're called square inches. And algebraically, it makes sense that the units are squared, because if we're really careful, what we're saying is we do 3 inches times 4 inches. 3 times 4 is 12. And just like x times x is x squared, inch times inch is inch squared. So it really is 12 inches squared, or 12 square inches. So our formula for a rectangle is going to be base times height, because all it's doing is quickly adding up rows and columns of squares. If you had a base of 7 and a height of 2, that means you have 2 rows and there are 7 columns. So 2 times 7, 14. So as we go through this chapter and we come up with all these formulas that I'll be explaining, you may want to make flashcards for yourself, or a sheet of paper with a list, a Google Doc with all the formulas. So that's the first one. As long as you know that first one, we can prove all the others. A square, for example. Well, a square, we know from chapter 4, is a rectangle. It has 4 right angles. So we could say base times height. It is a rectangle, but on a square, since the side length here is the same as the side length here, more commonly we would write the area of a square to be the side squared, because it's the same base and the same height. So why use 2 variables when you can use 1? Side squared. How about a parallelogram? So let me bring this into view. Here is a parallelogram. It is 4 inches across on the base. That's the 4. And when we say height in all of these formulas, we mean the length of the segment that's perpendicular to the base. So on this rectangle, this is the height because we know that's a right angle on a rectangle. So that's the segment that's perpendicular to the base. On the parallelogram, this is not the height. That's not perpendicular to the base. This would be the height, making a right angle with the base. And what I want you to see with this is a parallelogram in terms of area can be thought of as a rectangle in disguise. So the amount of paper used to make this rectangle is the same amount of paper used to make that parallelogram. They have the same area, equal area. Let me flip it over. This is the same rectangle. 4 units across the bottom, 3 units high. And since I'm using the same amount of paper here as I am here, they have the same number of square units inside, 12. Now some of the squares have been cut up here, like this is not a full square, but we can see that this piece and this piece combine to make a full square. So there are 12 square units inside this parallelogram, and if we think about a formula for it, notice the base of the parallelogram is made up of these 2 pieces. Back in the rectangle form, it's the same 2 pieces. So the base length of this rectangle is 4, the base length of the parallelogram is 4. How about the height? This is the height of the rectangle, perpendicular to the base, but notice that it is also the height of the parallelogram, perpendicular to the base. So, same base as this rectangle, same height as the rectangle, same amount of paper, same area. That means it's the same formula. The area of this parallelogram with base 4 and height 3 is base times height. Just a rectangle in disguise. So there's our third formula. Now, if this were middle school math, I would just be giving you a whole bunch of problems that looked like this. I'd say, here's a parallelogram. The height is 3, the base is 5. Find the area. And you'd be doing base times height. Answer is 15. How boring would that be, right? So what we're going to be doing is hiding the information you need. So I want you to get a good shot of all 3 of these pictures. We'll let the cameras focus in. And once you've got a nice shot of all 3, hit the pause button and see if you can figure out the area of all 3. I'm going to unpause. I'm going to resume in 3, 2, 1. All right, let's see how you did. So these are parallelograms. I suppose I should have been clear and said that before you hit pause. You probably assumed. These are all parallelograms, so they're all going to be base times height. Let's start with this one. Base isn't given, but I know on parallelograms, opposite sides are congruent. So top is 26. This goes back to chapter 6 and your best friend that we used to call it. Properties of parallelograms we proved. 26 centimeters here, minus 17 tells me this is 9. Most important thing we've learned this year, Pythagorean theorem. Missing side, 9 squared plus x squared equals 15 squared. That's a triple, you get 12. So, base is 26, height is 12. Base times height, 26 times 12. Answer, 234 meters squared. So you see how once you find the base and the height, it's a pretty straightforward problem. Let me double check something. That's not right, is it? 312 meters squared. 312 meters squared. 26. That mental math didn't look right to me. 312 meters squared. Okay, this one. Let's see. We don't have the base or the height. So these x's seem like they might be helpful. What do we know about these? These are consecutive angles on a parallelogram. Second most important thing we've learned this year is angles on parallel lines. These are same side interior angles. They must be supplementary. Consecutive angles of a parallelogram are supplementary. So they total 180. This plus this, 3x equals 180, so x would be 60. This is a 60 degree angle. This is a 2 times 60, 120 degree angle. Opposite angles congruent on a parallelogram. Just filling stuff in to see if I find anything helpful. Finish off my triangle. Well, this seems helpful. 30, 60, 90 special right triangle. If that's 10, opposite's 10. All right, how do I dance around a 30, 60, 90? If I know the hypotenuse, I divide by 2 to get the short leg. And if the short leg is 5, the long leg is 5 root 3. Oh, if only your geometry teacher warned you how important the special right triangles were going to be. Oh well. So let's see, how long is the base? 6 plus 5, 11. And the height perpendicular to the base is 5 root 3. I don't see the words round off written anywhere in the directions. Exact answer would be 55 root 3 centimeters squared. How about this one? Well, we know on a parallelogram, opposite angles are congruent. Well, that seems important. That seems special. Pardon the pun. Special right triangle again. How do I go from hypotenuse to leg on a 45, 45, 90? We divide by root 2. No square roots in the denominator. So we're going to clean it up. Numerator, 8 root 2. Denominator, root 2 times root 2 is 2. 8 over 2 is 4, so 4 root 2. That's this, and because it's isosceles, that's also this, which means my whole base down here is 5 root 2 plus 4 root 2, 9 root 2. So the area is going to be the base, which is 9 root 2, times the height, which is 4 root 2. 9 times 4, 36. Root 2 times root 2 is 2. I guess my answer is 72 feet squared. One last one for you to look at and hit the pause button. It comes from the book. Can we get a shot of that paragraph and that picture? Let me know when you got it. All right, kids, hit the pause button, give it a shot, and then I'm going to show you my solution. Here we go. So first of all, did you catch that it says amount of carpeting needed to cover just 3 of the rooms, not the whole thing? Did you catch that it's sold in square yards, but the measurements were given in feet? So there's conversions we have to do. One of the rooms we need is the hall. The base of the hall isn't given, but we can see that up here there's a length of 35. So down here is a length of 35. So that missing piece must be a 5, right? So we want the area of the bottom 3 rooms. The living room, the den, and the hall. Living room was 15 feet by 13 feet. Area of the den, that would be base of 15 feet and a height of 9 feet. And the hall, base 5 feet, height 13 feet. Now, to convert into yards, if there are 3 feet in a yard, every 3 feet is only 1 yard, then we need to divide by 3. 15 divided by 3 is 5. 13 divided by 3 is 13 thirds. So I divided each of these numbers by 3. And then you could really, at this point, you could just grab your calculator and type this in. So this times this, plus this times this, plus this times this. I did out one more line of work on my paper. So the living room came out to be 65 third yards squared, and the den is 15 yards squared, and the last one is 65 ninths yards squared. And when you add those together on your calculator, you get 43.8 repeating. This is a real life problem. You can't go into Home Depot and ask for 43.8 repeating square yards of carpet. Well, you could, but you'll get thrown out. In real life, it said you'd have to buy, it said they sell it in square yards. So you'd have to ask yourself, do I buy 43 or 44? Well, if you want to carpet everything, 43 is not going to be enough. Even if this was 43.1, we would still have to go up to 44 square yards for the answer. One last thing I want to point out. Some of you might have been thinking, can't I just use these numbers and get the answer in square feet, and whatever that comes out to be, divide that by 3? And if you try that, you'll see that you get a different answer. I'm actually typing it into my calculator right now to show you. If you type all the numbers in feet into your calculator, you get 395 square yards. And you divide that by 3, you don't get the right answer. I'm sorry, this is square feet. And if you want to turn it into square yards, dividing by 3 doesn't do it. You actually have to divide by 3 squared. If you divide that by 9, you get the right answer. And the reason that happens is if this is 1 yard and this is 1 yard, this is 1 square yard, but each yard is 3 feet. So this is 1 foot, this is another foot, and a third foot. 1 feet, 2 feet, 3 feet. So 1 square yard does not equal 3 square feet. It actually equals 9 square feet. So keep that in mind when you're doing your conversions. One other example would be if I want to turn feet into inches, I multiply by 12. But if I want to turn feet squared into inches squared, I don't multiply by 12, I multiply by 12 squared. So that's something to mull over. Good luck with the assignment.